Hello, my name is Nam Chuang. Today I will go over the one of the calculus AB practice problem. It's about the position, velocity, and acceleration. So here is the one of the example. And when I look at this one, then we can see that, all right, so we have see the velocity here, right? And we see the position, and we see acceleration and speed. Right, so I just scan over something about this, and we can see that um, this is problem about relationship between velocity, position, and acceleration. So let's get started with what we need to know about the relationship between them. So let's S uh, be the position function, then Vt is a velocity function, and at is acceleration function. Okay, and then I can see that the relationship between this function is we know that velocity is equal to derivative of velocity is acceleration, derivative of position is velocity, and then from here we can have the inverse operation is integral of acceleration uh, is equal to velocity, and integral of antiderivative of velocity uh, is position. And that's the relationship between them. And from here, you can see that acceleration is second derivative of position. So that's obviously we know. And then I see the speed here. Oh, velocity and speed, they are different. So typically, velocity that has direction, and speed is a number. It doesn't have direction. So typically, we can say speed is equal to absolute value of velocity. So it never get. It's always positive. So it's never get negative. But velocity could have positive or negative because it's go to direction. For example, if we go to the right, then velocity is positive. We go to the left, the velocity is negative. Or typically we go up, velocity is positive, and go down, velocity is negative. All right, so for this problem, they give us their um, velocity function. Then they ask us to find acceleration, right? So we know that in order to find acceleration, if we know the velocity, then we just take the derivative of velocity. So we have at equal to derivative of this. Over here, we use product rule. Product put the negative of derivative of the first one will be the negative 1 times sine of t squared over 2, and plus negative of t plus 1, and we time derivative of the second one here will be, we use a chain rule, so we have cosine of t squared over 2 time derivative t squared over 2 is 2t over 2. All right, then we simplify a little bit, so we have negative of sine t squared over 2, um, and then minus, and this one cancel, t times t plus 1 times cosine of t squared over 2. So that is the acceleration. But they say that acceleration of the particle at time equal to t. So you can just substitute t as number 2 to number t. Substitute 2 to t. So you have negative of sine of 2, And then you substitute 2 in here, they have minus 6 cosine of 2. All right. So if we use the let's use the calculator to see what do we have here. All right. So we have let's type sine of 2. Oh, minus sine of 2. Let's say minus sine of 2. Minus 6 times cosine of 2. Okay, so we have 1.59. So is equal to 1.59. So this is a positive number, right? This is a positive number. Now they ask us the speed increasing or decreasing. Oh, so we know that about the function we learned about increasing or decreasing is this. If the function is increasing, that means equivalent to the derivative is positive. If the function is decreasing, then that means the velocity is negative. So we apply in here, then we have that. Let's ignore the speed right now. So let's think about velocity so far increasing. That means we have velocity increasing, the equivalent to acceleration is positive. Velocity decreasing, that means acceleration is negative. All right, so let's see, because acceleration is positive, all right, so that means velocity is increasing. All right, so let's see, but velocity increasing, it doesn't mean speed increasing, because we can take a look at this right now. So let's take a look at v of 2. At that moment, what's this value of v of 2? So we substitute 2 in here, so we have negative 3 sine of 2. All right, so let's do that. So we have negative 3 sine of 2. Right? Oh, that's been negative 2.73 is equal to negative 2.73. Oh, velocity is negative, and that means at that moment, speed is equal at that moment is equal to 2.73. So speed is positive. But think about velocity increase, but velocity is negative. Let's draw the line here so we can see it's 0 right here, and we have negative 2.73. Velocity increase. Let me have to go this direction. The next one could be 2.7. It could be 2.7, negative 2.6. But think about if we take the absolute value, the speed will be opposite in this direction. The speed will be 2.73. And then next line will be 2.7, and it's go to 2.6. That means look like the speed is going to that direction. That means the speed is in decreasing, not increasing. At t equals to 2. So that's a tricky part of this question. This is very tricky because they ask you speed increase or decrease, but they didn't ask you velocity. So be careful of this trick. So far so good. All right. So the next question is they ask about the find all the times t in the open interval 0 to 3 when the particle changed direction justify your answer. Right? So um, the particle change direction. So this one is key. Particle change the direction. So that means the velocity changed the sign, right? Velocity change the sign. Velocity change the sign. That means velocity go from negative become positive, or velocity go from positive become negative. So at this moment, the velocity must equal to zero. So in order to know when the particle changed the direction, we have to let the velocity is equal to zero. All right, so we solve that question. You have negative of t plus 1 times sine of t squared over 2 is equal to 0. Or this one, that means is equal to t plus 1 is equal to 0, or sine of t squared over 2 is equal to 0. But this one has been t equal to negative 1. We don't accept this case. So sine of t squared over 2 is equal to 0. Then we can solve the equation like this. Okay, we can solve the equation like, and then we have t squared over 2 is, if you look at the unit circle, right, the unit circle, sine is this is a sine axis, this is a cosine axis. So sine equal to 0, that means it's go to this position or that position. So that means, but this one is 0 is equal to 0, or t squared over 2 is equal to, here is pi, or t squared over 2 is equal to 2 pi, so on so forth. But we need, it has to stop because there's a constraint of t right here, t between 0 and 3. Then we know that this one, t equal to 0, we don't accept this case. This case, that means t squared is equal to 2 pi. Then we have t is equal to plus minus square root of 2 pi. However, t cannot be negative, so we accept the 2 pi only, square root 2 pi only. So let's see, what is square root of 2 pi? All right, we have square root of 2 pi. This is 2.5. Is equal to, so t is equal to 2.5. We don't accept the negative. I think that's enough because we don't want to go further because we know that it will pass 3, right? So we just choose t equal to 2.5. Then we draw, that's where, then we it's 0, but it's not enough. That's where the velocity equals to 0. But it doesn't mean that the particle change direction, it have to be from negative to positive. What if both of them is positive, then it can take 0, but it's go to positive direction. It could be the case. So what we need to do next is we uh, uh, draw the chart of the sine t, and this is 0 to 3, and we have 2.5, and this is vt. We know it's 0 right here. Let's see, 2.51. Okay, 2.51. All right, so then we pick up a number here, we substitute into the velocity, then we can see what happened. First of all, we can substitute 3 in there, so we have negative 4 sine of 9 over 2. So we have negative 4 and a sine of 9 over 2. Oh, it's a positive 3.9, so this is a positive. And we substitute 0 in there. We know the sine of 0 is 0. Sine of 0, 0 is not a good candidate. We substitute 1 in here. Then we have negative 2 sine of 1/2. Negative 2 sine of 1 over 2. It's negative. Oh, that's good. That means at this moment, the answer is at this moment t is equal to 2.51, the particle change, from the negative to the positive direction to the. So that's how you solve the problem about the position, velocity, and acceleration. So let me summarize what we learned in this section is, first of all, we need to know that derivative of position is velocity, and opposite inverse is in antiderivative if velocity is equal to position. Derivative of velocity is acceleration, and antiderivative of acceleration is velocity. We also make sure that speed is absolute value of the velocity. It doesn't have direction. And when the velocity increasing, that means the acceleration is positive. Velocity decreasing, acceleration is negative. We have to be careful about the speed increasing here. Doesn't make sure there's not the velocity is increasing or decreasing. One more thing, that a particle change direction, that means we let the velocity equal to zero, but that's not done. Make sure that you have to have the sign table here. That means the velocity change the sign from negative to positive or positive to negative. So that's important to know that. Make sure that you make that last step to make sure that the particle change direction. All right, so that's it for today exercise. Thank you for watching and see you next time.